Okay, I got a stereo set of handheld spectrum analyzers, and this is my colleague's and this is mine. So mine is a 40B and his is a 42CN, so it has a larger range, and it's a much newer version of firmware. When I wrote stuff, his behaved differently, mine behaved differently, so I had to figure out the discrepancies between the two, and I figured them out. It's mainly the way that this one extracts trace data. And there's a couple things that turn the high sensitivity and the preamp on just a little bit differently. But I'm on version 10.7.7. It's starting to look better. I got a dark mode going. I guess I'll start from. So I'm going to disconnect the unit. There's a drop down menu, so if I had both units hooked up, I could choose which one I want. Because I'm using that one, I'm going to connect. It does a connection. It checks the current settings, and it also sets it to the settings that I care about. But it also extracts device presets. So he's got a whole bunch of device presets that he uses on a daily. And it extracts those, so he can just select that and hit go. He uses Mon as a naming. So I made the monitors blue so he could see them quicker, and then it just tunes to those ranges. Up here, reference level, high sensitivity preamp, scan RBW. So this is the scan of the CSV that it ultimately puts out. Hold time, so it's kind of like a dwell. The dwell, it sits there. It does a max hold or a min hold for 3 seconds. Scan name. I was up late, so it's called go to sleep. Final test. So this is a folder name, so it creates the folder name. You can click open folder. It is there. When you plot, do you want the TV markers? Do you want the government markers? And then open the HTML. I also have this generate plot. So when it's done doing 10 or 15 scans, you can go generate plot average, and it'll generate a plot. This is what an average plot looks like, and it's really quite spectacular in terms of a couple different maths are applied to it. So I have green. You can't really see it in there because it's right over top. That's the median. I have blue, which is the average, and then I have range. So sometimes what happens is the average hides some details, right? So there's a lot of information there being hidden in the average, but it shows up in the range. And this graph is very interactive, so I can push home. It's got all the TV markers and everything over top of it. It's a lot of data. Like, this is like 100,000 data points per scan. So here, let's just zoom in on a TV channel. Let's pick a TV channel. So you zoom in on it, and there's TV channel 24, TV channel 22, TV channel 29, and all the information associated with it. And you can go in, and you can hide data, and you can. I just did a small selection. This HTML file is huge. I've never generated an HTML file so big. I believe the HTML file, it's 120 meg HTML file, which is redonkulous. The historical data, though, I create a CSV of that, and that CSV has the frequency, it has the average, it has the median, and it has the range in it, and that's what generates that CSV file. Well, that's what generates the average traces. The program has gotten kind of unwieldy. I'd like to make it several Python files, but for his convenience, one is enough. So it's past 2,000 lines, and it's pretty bad. But it initializes the instruments, and this is where it gets different. So if the preamp is on, here it does this. Preamp is weird. If the device is so what's this function? Okay, so this is the scan bands function. So it knows that the two different devices behave differently. Okay, so I just want to find a section where time sweeping, hold time. Okay, so here. So if the instrument model is this, query this way. If the instrument model is this one or any other model, it's just subtly different. So when it turns on, it actually knows what, I don't know if you can see that. It actually knows which device is connected and does that. Plot single data, there's that. Just it's unwieldy. Puts all the text on, spectrum analyzer control. This is the app itself. So the app itself is all defined in here. How all the scroll bars work. To do gray mode, you have to specify that everything is a certain color, and all of that can be modified. That was a fun time there. Update progress labels. There's functions for absolutely everything. A lot of error handling. Query instrument settings, just to see what's going on. Query the presets, right? So here it's actually going to the C drive of the device and querying the catalog, and then splits the response based on CSV colons. Jeez Louise. Can't parse it, the error handling for that. If the file is STA, then it makes a complete list of those. If the STA, see here, check if it has the monitor tag. So if it has the monitor tag, make those blue. So much iteration. Stop scan. So when you hit stop scan, it stops everything. When it pauses the scan, it pauses properly. A lot of error handling in terms of that stuff. And it also still installs all the dependencies. So if you don't have the right dependencies, it's all there. The other thing I did was I put the frequency band definitions in a separate Python file, just for now, because when you're putting it into an LLM, I'm using Gemini for this project, it regenerates this list every time. So it's like 150 lines or 134 lines that I don't have to sit there and wait. I'd like to split this project into multiple things and then compile it for him, but just for now, it's good enough. This is last night's scans, and so each scan is about 2.5 megs of data, and each one, and you can select how you want this to go, so you can choose which band you want to be a part of, so you can have UHF or VHF or high bands, low bands, whatever you want, and then you can choose the RBW, so you can really have a polished scan. 125,854 lines in that scan. So it's got a ton of data, and then each one of those generates its own graph. So I have a graph of each CSV, so you can actually go in at a certain time. Is it useful to have a graph of each one? Well, yeah, if you want to go back in time, it's like a time machine for spectrum analysis. But the average is really, really where the money is.